Question 1 asks us to find the cross product of two vectors a and b. So the first thing I'll do is to write out the formula for the cross product, and I'll do it how I normally do it when I can't remember the formula. So I write my two vectors a and b, and they each have components x, y, and z. And then if I start with the I component, my cross product is ay, bz minus az, by, and that's in the I direction. And then I'll do my j component, so that's the x and z components of a and b. And then finally I'll add my z term, which is my x and y components. Okay, so now I have my proper formula for the cross product. I'll write out my two vectors a and b. So a is 0, -5 and 10, and b is 0, 9 and 6. So since the x components of both a and b are 0, that means I can get rid of any x components in my cross product formula. And that leaves me with the formula that my cross product is ay, bz minus az, by in the I direction. And so then I can just substitute in my values. So ay of -5 times bz of 6 minus az of 10 and by times by of 9. That gives me -30 minus 90, which is 120, and that component's in the I direction. In question 2, we're asked to find the magnitude of the cross product of two identical vectors. So I'll call my vector A. And I know the magnitude of my cross product is then equal to the magnitude of A times sine theta. So that's a squared sine theta, where that theta is the angle between the vectors. And since the vectors are identical, theta is equal to 0. So therefore, the magnitude of my cross product of two identical vectors is 0. And so this extends to any two vectors that are in the same direction. Even if the vectors themselves are not identical, if the direction of the vectors is the same, then the cross product will always be 0. And the final question in part 3 asks us for the direction of the cross product of two vectors a and b, where a and b are both in the xy plane. So we know that the direction of the cross product is perpendicular to the plane that the vectors are in. So that means in this case, the direction of our cross product is perpendicular to the xy plane. So therefore it must be in the z direction. The other way that we can do that is we can again write out our cross product equation in full and substitute in the values of our vectors. So since a and b are in the xy plane, that means they have x and y components, and their z component is 0. So when we put that into our cross product formula, we find that the only non-zero term is the k term, so the term in the z direction. So we find that the direction of the vector, once again, is in the unit vector k direction or in the z direction.